Hi folks, it's Peter here. I want to do a very quick introduction to the Truss library for Clojure and ClojureScript. So Truss is a micro toolkit for handling exceptions, errors in Clojure. And basically it's a set of utilities which I've written over the years, which I found particularly helpful for dealing with errors. That is, producing helpful errors, writing unit tests relating to errors, and in particular dealing with Clojure's exceptions, which are sometimes a little bit difficult to understand or to debug in production. So there's a wide range of stuff in here, but they're all pretty simple. I will start off here with showing you the contextual exception. So a basic Clojure xinfo will look something like this. My xinfo bar, we've got our data map, and over here is the exception that's thrown. So Truss has something very similar. Truss xinfo, xinfo. So this over here is producing the same class. So it will be caught by the same catch blocks that you already have. It's a standard xinfo, and we're taking advantage of the convenient data map, which is available for exception info, and we're basically just adding some default info in here, including the namespace of the call site of the exception, the coordinates, so the line and column number of the exception. We've got our standard user supply data in there. Additionally, we have this with context macro over here, which allows us to take any sort of arbitrary data, so for example, user ID. And if we have a exception which runs, which is generated over here, we include under the Truss context key whatever the dynamic context was at that time. Yes, so this is useful basically if errors occur in production. Often you don't have, often they don't contain a huge amount of information to help understand what actually triggered the error. For example, what was the program state at the time, or what arguments were you running with, that sort of thing. And with context just gives you a convenient way to add context to your exceptions for the dynamic code executions. For example, one common idea would be if you have something like a ring handler, and it takes a ring request, you can do something like this with context, or we'll use over here the with context plus, which is basically just merges the value that you're going to provide in case there's already a pre-existing context. So we'll do something like ring request right here, and then you have the rest of your handler body, right? So the idea is if something unexpectedly throws in this body, we will have the ring request as part of the X data. So to help us debug, to understand, what params were there, what URI were we on, etc. Or maybe to make this a little bit more general, you could have something like wrap context, and then you're going to have handler. So this would be a ring middleware. Then we're going to have something like ring request, Truss with context, ring request over there, handler, ring, something like that. So this would effectively wrap our handler, which you could put at a high level in your app, so that as you have requests coming into your ring server, you're setting up this dynamic context so that if any Truss exceptions are thrown in the handling, you will have the context of the ring request. So it's just a little convenience thing, but can be quite handy. Okay, second is cross-platform utils. So there's Truss error, super simple, just basically returns true if you've got a JVM throwable or a ClojureScript.js error. There is also this try util, which basically gives you, it operates just like a try, standard try from Clojure or ClojureScript, except that your catch clause, instead of just having a usual, throwable or class type that you're catching over there, you have access to a set of special keywords. For example, you can specifically catch if you want an xinfo port. Oops, excuse me, throw exception. So this will not catch, it will throw. But if we do an xinfo, that will actually catch. And there are a few different things over here which are useful. In particular, I'll draw attention to this default case, which handles a bit of a sharp edge with Clojure, which is that assertions in Clojure, unfortunately, throw an assertion error. An error is not an exception, which means that if you're trying to catch exceptions and assertion errors, it can actually be a little bit tricky sometimes to do that. It's a bit laborious. This anyway provides a way of doing that, which is also the default case in Truss, is that it will catch exceptions and assertion errors, since that's commonly what you actually want to be doing. Anyway, so that's pretty simple. Close all of these. Hang on there. Okay, next up, throws. So yes, it's often the case that you want to be writing unit tests that check whether your code is throwing the correct exceptions that you're hoping it will throw in certain cases. And there is this util over here called throws, which basically will return true if you have a matching exception. So there's a few ways of calling this. Most basic over here. Xinfo. Excuse me. Actually, this is just going to be any xinfo. Xinfo bar. Okay. So this will be true over here because we are this code over here is indeed throwing an xinfo. This kind over here is the same as the kind provided to try. Oops. So we have access to all of these. So, for example, default over here. Okay, but we can also, excuse me, there's also a optional pattern argument over here, and the pattern argument can be a number of things. Over here it can be a string, a regex, a map, a set of patterns, and so on. So to give you some ideas, over here we can do something like my xinfo. What is happening here? Oh, excuse me. Xinfo. So this is the priority case. So this will give us a match over there because it's matching the text and the myxinfo, and it's a contains type match. So that should also match. But if we have not xinfo, that won't match, for example. Or we can use a map over here if we want to match against the x data, so the map over here which is attached, and this works as a submap. So this will also match because foobar is a submap of this over here. And we can use regexes, or we can use a set if we want to match any of a set of things. So we can, for example, have the foo, or we can have bar. So that would work. If we disable this one, it will still match. So anyway, there's more information in the doc strings about how this works, but basically allows it provides a concise way of doing a wide range of matching for your unit tests, and it has a number of nice little sort of quality of life things, like, for example, if a particular exception or error doesn't match initially, it will attempt to go up the causal chain to see if there's a match up the chain, which means that you can easily wrap exceptions and so on without breaking your unit tests. So that's the throws. Okay, good. Misc utils. So one thing that I find myself often wanting to do is just swallow exceptions in some contexts. So this catching macro does exactly that. It expands to this, which means basically if we have something in here, it's just going to return nil, swallows the exception. Nice and simple. Next up, we have catching RF and catching xform. Catching RF. Catching xform. So basically, these are intended to help you reinforce your reducing functions and your transducing functions. transducing functions in particular, but this is also true for reducing functions, can be quite difficult to debug in production if something goes wrong. Because again, the error messages generated by default are not terribly useful, and because they can be quite, especially transducers, can be quite complicated conceptually to understand. It's very easy to, let's say, to have the wrong idea of what they're actually doing. So let me show you some examples. Let's do a simple reduction. Do something like this. Let's say the initial value is nil. Range. So this should throw, and this is throwing over here with a not terribly helpful error message. But basically, what's happening is we're starting with a nil accumulator, and then we're trying to add a number to a nil, which throws, and again, throws this thing, which isn't super helpful. So what we can do in this case is use Truss catching, RF. So we just wrap the reducing function. And now when this throws, it gets wrapped with extra information which can help us debug. In particular, we've got the namespace of the call site. We've got the coordinates of where it occurred. We've got the reducing function. We've got the actual call. So this is helpful, particularly in the case of transducing functions, because transducers have multiple arities, and sometimes it's a particular arity that's giving you problems, right? So it might be the completing call, or it might be one of the non-accumulating calls that's actually throwing. And anyway, this just gives you some context so that you understand specifically which arity is it that's throwing. And then over here, we've got information on the arg. So the accumulator's value is nil, the type is nil, the input value is 0, and the type is long. So from this additional context, it becomes easier to understand what's actually happening, because you understand, look, it's specifically the call where the accumulator is nil and the input is 0 that's throwing. So I'll show you an example as well using transducer. So let's do something like this. I think. Okay, range 10. So this should work. So over there, our transducer is this map inc, and we are just incrementing all of the input numbers. That's fine. But if we add, let's say we add a nil onto this, this should throw. And again, it's throwing an error message, which isn't particularly helpful. It's a little obscure. And what we can do to help make this easier is wrap the transducer over here with catching X form. And you'll see, again, this produces now a wrapped exception. It's adding the namespace and the coordinates of the call site. We've got the reducing function. We can see again here, it's actually the two arity version, which is throwing. That would be, for example, RF ACK if it were the 1 arity, or just RF if it were 0 arity. And we've got the args over here. So the accumulator value appears to be a transient vector. Type over here as well, and the input is nil and nil. So again, this just gives you some more information if one of your transducers fails in production. They can be a real nightmare to try and understand what actual inputs caused the problem. And again, with the combination of the contextual stuff for your X info over there and this, it just gives you a lot more context to understand what state was your program actually in when an exception was thrown. So that can be quite helpful. Finally, we've got the assertion utils. So I'll keep this brief because these have been in Truss since version 1, and there's I've done some previous videos on these, but effectively these allow you to assert any arbitrary predicate against forms. So for example, hello, this will be true, but if I put a number in there, this will produce a fairly detailed error message, which again gives the namespace, it gives the coordinates of the failure, the time when the failure occurred, the predicate that was being checked, and details about the argument for which the predicate failed. So this is handy in cases where you have, let's say, some sort of a function, I don't know, let's say username, I don't know. And we have user ID, user, and let's say hypothetically we want to insist that user ID is a number. What we can do in this case, have, let's say it's an integer, user ID, okay, username, and if we put in a user ID of 101, that's fine. And if we accidentally put in a string, for example, this will now give us a detailed exception with a bunch of information that should hopefully help us understand what happened if this pops up in production. Now, the Assertions API is quite extensive. There are a lot of features. You can apply or check predicates against a set of things. Bar, so against arbitrary collections, and this will correctly indicate which specific input was failed. Or you can, for the purposes of destructuring, have, let's say, integer, and then we can have different something like this over here. That's good enough. Excuse me. So if we put in two integers over here, 5 and 10, that will be fine. If we accidentally put in a string over there, it will complain about the specific input. So again, the idea is in cases where you have a very specific type requirement, or you have some sort of other, let's say, invariant in the state of your program or your code that you want to make explicit, you can reinforce that using the Truss assertions. And if something goes wrong, you get a helpful error message. There are variants of the Truss assertion macro that I've shown you over here. This one returns truthy. So this one over here returns its argument if the predicate passes. Over here, this will return foo. And with the question mark, we'll return true, which can be useful if you're using it in preconditions or something like that. And there's another variant with the bang, which behaves just like this one, except it can't be elided. These are subject to closures, value of closures assert, so theoretically they can be elided if you want extra performance. These ones cannot, will never be elided. So for cases where you want to do some sort of an important security check or auth check or something like that, you may want to use the bang variant in case you are otherwise sometimes eliding assertions. And anyway, I think that more or less covers the main stuff. Everything should also hopefully be clear from the doc strings. It's nothing super complicated. It's a very small library. Most of these utils also require a little bit of work from your side in order for them to be useful. For example, it can take a little bit of work to set up relevant context. There are sometimes tricks to setting up context with relatively low effort, like the ring middleware that I showed you, where you can just set up your ring request on all of your handlers in case any of your handlers throw a Truss exception. But these are not, let's say, these are not silver bullets for making your life completely easy with exceptions, but they are a helpful set of tools that I think offer really good, let's say, value for effort. And anyway, help to smooth over some of the rough edges of what I believe to be some of the rough edges of exceptions or error handling in Clojure and ClojureScript. Hopefully that is helpful, and that's it.